Hello friends, I welcome you to the session on colloidal dispersions. This is the first session on this topic. In this session, you will see what are colloids, the pharmaceutical applications, their properties, different types of colloids, and their preparation method. This chapter is very useful as it will form a base for your future formulation related aspects. So let's begin with the session. This is colloidal dispersions part 1. Myself Tosha Pandya, Assistant Professor, LG Institute of Pharmacy. In this first presentation, we are going to see about what are colloids, the comparison of solutions, colloids and suspensions, the pharmaceutical applications of colloids, the characteristics of the dispersed phase, and we will see two types of colloids here, lyophilic colloids and the lyophobic colloids. So what are colloids? Colloids are polyphasic systems in which at least one dimension of dispersed phase ranges from 10 to 100 angstrom to a few micrometers. It consists of a dispersed phase, which is an internal phase, and dispersion medium, which is the external phase, in which the size of dispersed particles is between 1 nanometer to 100 nanometer. The particles, as you can see here, in the colloidal solution are not as small as true solutions, that is the homogeneous solution, but they are not as large as suspensions. The colloids cannot be seen by simple optical microscope. You need ultra microscope or electron microscope to visualize them. Now this is the comparison of true solution, colloids and the suspensions. They are classified based on various properties, right? As you can see, particle size. The particle size of colloids ranges between true solutions and the suspensions. It is between 1 to 100 nanometers. Appearance is cloudy. It is not clear as the true solutions. Homogeneity, they are homogeneous or heterogeneous solution depending on the size of the dispersed phase. Transparency, they are often translucent in nature and opaque, but can be transparent also sometimes. Separations, they can be separated only by centrifugation. And for filtration, they pass through filter paper. And example, you can see for true solution, the salt in water solution is a true solution. Okay, it is homogeneous in nature, whereas milk is example of the colloidal dispersion, and suspension is the floor suspended in water example of the suspension. Now the pharmaceutical applications of colloids. Due to the small size, they find various pharmaceutical applications, as you will see below. Therapy. Due to the small size, they have better absorption, and the best example is silver. Because of the small size, it has germicidal action. Absorption and toxicity. The colloidal sulfur, because of the small size, has higher absorption, but at the same time, due to higher absorption, it will present greater toxicity in blood. Solubility. An insoluble drug, phenobarbitones, are solubilized by micellar solubilization. Stability. Yes, the colloidal dispersions can be used to stabilize tablets. They are used as tablet coating. Targeting, because of the small size, they can be used for targeting purpose to the liver and spleen, and even to the cancer cells. Examples are drug entrapment, liposomes and nanoparticles. Now the characteristics of the dispersed phase. Due to the small particle size, it will influence the color of the dispersion. The wavelength of the light absorbed is inversely proportional to the radius. Means smaller the size, then higher the light absorbed in the larger wavelength range. Whereas larger particles will absorb in a shorter wavelength range. Example is the colloidal gold will absorb in the Vibgyor region in the red, that is a larger wavelength. Small particles, large wavelength. The colloidal gold appears red in color, whereas the coarse dispersion of the gold at the same time will appear blue in color, that is it will absorb a shorter wavelength of light. The particle shape also influences the color of the dispersion. As you can see, you have various shapes of colloidal dispersions. They may be spherical, they may be rod-shaped, flakes, threads, or ellipsoidal. The gold particles, when spherical in shape, appear red in color, whereas when they are disc in shape, they appear blue in color. You can see that the shape difference also influences the color of the dispersion. Surface area, smaller size, larger the surface area, and hence it help them to be an effective catalyst and to enhance the solubility. Surface charge, that is also one of the characteristic of the dispersed phase. The positively charged, example gelatin, albumin; negatively charged colloids, example acacia, tragacanth, and this charge helps them for stability. So if they have like charge, it will induce repulsions and aid in stability of the whole dispersion. Now, colloids can be classified into various types depending on various properties. They can be classified based on charge. So, based on charge, you have positive colloids and negative colloids. Positive example gelatin and negative example acacia. Based on states of matter, you have various types of colloids, solid, liquid, and gas, as you can see on the characteristics of the dispersed phase and dispersion medium. I will cite some of the example here. Example, solid in gas. So if the dispersed particles are solid and dispersion medium is gas, the best example are solid aerosols. Okay, or some solid particles which are dispersed in air. Okay, that are solid in gas type of colloidal dispersion. Now liquid in gas, liquid aerosols; gas in solid, the solid foams. Okay, so you can see based on the states of matter you have different types of colloids. The very important classification is based on the interaction of the dispersed particles and dispersion medium. How is the affinity of the dispersed particle and dispersion medium? Based on this, you have different types of colloids. So first type we have is the lyophilic colloid. Philic means it is solvent loving in nature. Here, as you have seen, it is solvent loving. There is greater affinity of the dispersed particles with the dispersion medium, and this gives them thermodynamic stability. Yes, because they have greater affinity, because the dispersed particles have greater affinity to the dispersion medium, the dispersion medium is forming a sheet around the particles and imparting thermodynamic stability to the dispersion medium. This has lead to easy preparation of the lyophilic colloids because the affinity is more between the particles and the medium. So the preparation is easy, and purification at the same time is also easy in nature. Moreover, they are reversible in nature. The colloidal dispersion formed can be easily reversed back to the original solution. Now in the lyophilic colloid also, depending on the type of the dispersed particle and dispersion medium, again you have hydrophilic colloid or lipophilic colloids. Both are solvent loving, but they are different in nature. Hydrophilic colloid example, solution of acacia and gelatin in water. Lipophilic colloid example, solution of rubber or polystyrene organic solvents such as benzene, ethyl methyl ketone, etc. Now, lyophobic colloid. The next type of colloids based on the affinity of dispersed particle and dispersion medium are lyophobic. Phobic means phobia, means they are solvent hating in nature. Here the particles have less affinity towards the dispersion medium, which makes them thermodynamically unstable because the solvent is not forming sheet around the dispersed particles. This leads to difficult preparation methods because there is less affinity between dispersed particles and dispersion medium. The preparation of this type of colloids is difficult in nature. Now, to impart stability, the particles must have repulsions between them, which will ensure uniform dispersion. These colloids are irreversible in nature. Examples are solutions of metals like silver, gold, salts of metal hydroxides, and salts of metal sulfides. Now let's see various methods of preparation of lyophobic colloids. The methods of preparation can be divided into two sets of methods. The first set of methods are the dispersion methods. Here you convert the particles of coarse size range to colloidal size range. The first one in this is the milling or grinding process, which is very well known to you. Here you convert larger substance to smaller size range with the help of mortar and pestle, which is then converted to a coarse dispersion, which is subjected to colloidal meal, which will convert it to smaller or fine particles. The next method, which is very important, is the peptidization method, which is done with the help of peptidizing agents such as glycerin or citric acid, which will accommodate in the coarse particles and break them down into smaller or colloidal size range particles. This can be done by addition of deflocculating agent or a surfactant, which will break down large particles to smaller size, or by removal of the flocculating agent. The next method are the electric arc method. Here you have, as the name suggests, you have electrodes involved, electric current is involved here. Okay, you have an anode and cathode, and with the help of the electric current transmission, the larger particles are converted to colloidal size range, which are stabilized with the help of potassium hydroxide. The ultrasonic treatment method. Here, the dispersion medium, which is of coarse size range, is subjected to ultrasonic waves, which will induce cavities or compression, and which will convert the coarse particles to the colloidal size range, which are stabilized with the help of surfactants. The next set of methods are the condensation method, which are reverse of the first set, that is the dispersion methods. Here you convert subcolloidal particles to the colloidal size range with the means of aggregation or condensation. Okay, your stable nuclei will attract ions or molecules on the surface, and the size goes to the colloidal size range. Here also two methods can be used. First is the addition of a non-solvent. So what is done here, you will add a non-solvent to a solution, okay, which will precipitate out the component of interest. So here the example is a sulfur solution in alcohol, concentrated sulfur solution in alcohol, which is soluble, okay, and you add excess of water to which sulfur is insoluble, which will precipitate out the sulfur, and this sulfur will grow to the colloidal size range. The next set of methods are chemical methods, but the chemical methods are not much used in colloidal preparations. So I hope you are clear with this much part of the colloidal dispersion. In the next part, we'll continue with another type of colloid and different properties of colloids. Thank you.